Hello students. So let's try to discuss a two very basic concept of fluid mechanics. So first is equation of continuity and second we will discuss Bernoulli's equation. So these two are very important for IIT-JAM examination. First we will discuss what is the actual concept and after then we will try to discuss different types of problems. So obviously here we have some assumption that our assumption is that during the motion, the density of a fluid is not going to change, and the motion is almost a streamline. So, if I am talking about motion is streamline, that means suppose there is some flow of a liquid. So, and we have 2 point. Suppose this is point 1 and this is point 2, and there is liquid is going to flow something like this, and if every particle or every element of liquid when it is reaching at this point A has velocity v1 and same direction and has velocity v2 as point 2, then it is identified as streamline motion. So that means every time when liquid will come here, it has speed v1, the direction is exactly same, and liquid will come there, its velocity or its speed is v2 and direction is exactly same. So if this kind of situation is there, then we can say the liquid has basically streamline motion. Okay, and so we have to discuss two main important theorem that which is very useful for fluid dynamics. The first is equation of continuity. So let's go for equation of continuity. So suppose we have this sort of flow, this sort of tube, and we have one cross section here. Let's say this cross section is A1, and let's say here is another cross section that is A2, and this is your area of cross section, and liquid is flowing into this particular tube, and the speed of liquid at this point or in this cross section when liquid is reaching it to this cross section, its speed is v1, and when liquid is reaching at this cross section, its speed is v2, and if liquid is is just doing the streamline motion, then what we have, a1 v1 is equal to a2 v2. So this equation is known as equation of continuity, and which is very important to discuss the dynamics or kinematics of a flow of liquid. Okay, and the second is more interesting. Suppose we have any fluid. So sorry, we have any tube, and this tube has this sort of shape, and we have reference line. Suppose this is surface of earth, and we have one point, let's say this is point 1, and we have another point, let's say this is point 2, and the height of this is h1, the height of this particular is h2, this particular point is h2, then, and the density of liquid is rho is density of liquid, and here we have pressure P1, and here we have pressure P2, and the velocity is V1 at this particular point, and velocity is V2 in this particular point. If I am talking about point, we are talking about this particular cross section. Then we will, then this whole system, the liquid which is flowing into this particular tube will follow Bernoulli's equation, which is nothing but the conservation of energy. And we are writing this thing in term of pressure basically. So we have P1 plus half rho V1 square plus rho GH1 must be equal to P2 plus half rho V2 square plus rho GH2. So we have this kind of situation basically. So if we have this kind of situation, and this is basically very famously known as Bernoulli's equation. So this is nothing but the kinetic energy. This will be just resemble to kinetic energy. This will resemble to potential energy. And this is extra pressure, extra force we are putting in this side and we are putting in this side. So whenever we have to solve problem, we have to use this equation and this equation simultaneously, and we can easily solve different types of problems. So let's try to solve different types of problem. So let's come to one very interesting and very beautiful problem. And in this problem, we have to use the equation of continuity as well as Bernoulli's equation. So here is some tube, and this tube is more or less conical shape, but here it is open. And if you will extend this thing, then it has shape of cone actually. But yes, at this point it is open, so the fluid can enter into this point, and the pressure at this point is P naught. The speed of liquid at this point is V naught. The speed is constant because it is a streamline flow. What we have to do, we have to write the expression of pressure as a function of x. So this is the whole idea. So what we will do, and we have to just plot the pressure versus x. So what we will do, at the distance x, we will take a cross section, this one, and we will just try to see how the speed is varied with the x. And obviously this is horizontal, uh, this is just in a horizontal position, so there is not any effect of gravity actually in this problem. So here we can, and this angle is pi by 4. So if we will extend it as a cone, then half angle is pi by 4. So this is x, then obviously this value, this by this, so we can write r by x is equal to actually tan pi by 4. So r, this is my r, radius of this particular cross section. So this r is equal to x tan pi by 4, that will be x. So what will be area? So this area A is identified as pi r square. So that will be pi x square. So this is area. And now we can easily use the continuity equation. So what is continuity equation? V naught into, we have some area at this point, and this area is nothing, that is A naught, it is also given. So this is A naught. So V naught into A naught is equal to Vx into Ax. So what is Vx? So Vx is equal to V naught A naught by Ax, and this is my Ax. So Ax is nothing but pi x square. So this is my speed of liquid, or every element of liquid at this particular point. Now, what we have to do, we have to just use the Bernoulli's equation. So when we are going to use Bernoulli's equation, the pressure is given at this point P naught, and this will be half rho, the density is constant, that will be V naught square. And obviously there is not any potential energy part there. So we have here Px plus half rho Vx square. So Px can be given by P naught, and that will be half rho V naught square minus rho Vx square. and we can take this row as a common. So this value is equal to half rho, and if we can take V naught square common, and we have 1 minus 1 upon pi x square, and plus P naught is also there. Plus P naught is also there. So what is my pressure at point X? The pressure at point X is equal to P naught plus half rho V naught square, and area is also there. So we have to use this one. So V naught into A naught. So here is A naught square is also there. So we have V naught 1 minus A naught square upon pi x square. So what we have? So we will start with at some x, we will start with some velocity. And when we are going to plot it, then obviously at x tends to infinity, this will be more or less constant, because this value is constant, this value is constant. But initially it has pressure P naught, and at x is equal to 0, it will increase, and after then it is just going to be constant. So this will be profile of pressure into this particular situation. So this was one of the very nice problem asked into your IIT-JAM examination. So if I am not wrong, this problem was asked in 2016. So that was in IIT-JAM 2016. So this is wonderful problem. You have to just use equation of continuity and Bernoulli's theorem, and you can easily see how velocity is changing, how pressure is changing, and everything you can calculate. So let's go for one more problem.